Do a small sound check. Testing, testing, 1, 2. Okay. Hopefully that won't echo too much, but we'll get there. Let me post this to Discord. Okay. Okay. So from last time, this is kind of the things that we're gonna do today, but let me cover what we did last time, and then I'll also cover. Get this closer. Okay, so I will cover what I did last time, and then I will cover what I did off stream, which isn't too much, and then we'll cover what we're going to do today, or at least what we're going to try and do today. So let's get to it. So last time, we basically took Fred buff. In particular, we took the Tree Walker, and we made it completely arena allocated. So we're not relying on standard library allocations here anymore. We're relying on the arena mechanism inside Fred. And this is working really well. This thing is always allocated on the stack. Like, I could pretty comfortably say if I deleted the Destructor, you would not find it outside of like an individual stack allocation. Maybe we could show that later, but for now, I think the point proves itself is that we're okay like stashing the arena here because it's like always a scratch arena and all that stuff. I also did off stream reverse Tree Walker. It was exceptionally trivial. It was basically the same thing as the Tree Walker. So I didn't think it was that important to show on stream what I was doing there because there was only like probably 3 instances of this thing being used since I try to reuse like the same function where this thing is used. So its transformation was completely identical, just a lot less intense as the Tree Walker, because this is by far the most common case that we're walking forward down the buffer, not backwards. So this one was pretty straightforward. I also, off stream, I took this selection list. So previously this was just a stood vector of selection, right? So it used to be something like this. And I got rid of that because I think the vector is just kind of like unnecessary. We don't, the contiguous allocation part of it is not strictly necessary for the way that this thing is used. And yeah, any chance I have to get rid of vector, I will definitely take it. So I just kept it as a list. We could probably add a join function down here just in case you did want an actual array of these things. Hey, Ratchet, good to see you. Yeah, I'm just kind of covering what I did off stream, or what we did last time, and then what I did off stream, and then what we're going to do this stream. Yeah, good to have you around. So these 2 functions, these are just helpers to help. I figured having these as part of the Fred buff API is just kind of useful, so you can kind of build these lists up and put them in the correct order and all that stuff. I don't leave that up to the caller. Or, I mean, you could do it if you really wanted to, but these are just helpers. And if you wanted a contiguous allocation of these things, like it was a vector before, I could probably add like a join function down here, but I haven't needed it, so I did not add it. So now selection meta just has this selection list, and it's up to the caller to maintain the arena for this thing. And I think that's worked out pretty well because everywhere this thing is used, right? We always have like this kind of local arena allocated for us. And in this particular case, it's from the clipboard manager. So the clipboard manager has it has like kind of this locally allocated selection meta thing, which tells us information like where all of the cursors were, if a selection was made and there wasn't any there wasn't like an active selection, but instead you push like Control C on a line without a selection. What that does in VS Code. So if I hit Control C right now in VS Code and you hit Control V, which is paste, right, you actually get the whole line. And Fred has that exact same behavior, and I think that's actually pretty important for just kind of copy and pasting lots of code around. And you could do it on a per cursor basis. So if I have like a couple cursors here and I hit Control C, each of those individual cursors then copy their own line independently. And so when you go to paste, like if you paste with one cursor, it does that. But if you paste with 3 different cursors, it'll kind of like copy them. And Fred has that behavior as well. And I can kind of show you what that looks like. So in Fred, if I copy this line, then I copy this line, then I copy this line. So Control C, so I copied them. And I go down to a different spot, like I want to put one here, here, and here, right? Boom. So they end up just like that, like you would expect. But if I just do it with one cursor, you get all 3 at the one cursor. So you have to have a proportional number of cursors to selections in order to get kind of like the linear behavior. Otherwise, you get like a duplicated behavior. So if I just have 2 cursors, it ends up just copying all 3 lines. So you have to have exactly 3 to get the one-to-one copy and selection. Anyway, that's what the selection meta tells us, and Fred knows how to process that stuff. And the clipboard manager is actually what owns that data, though, because if you copy to the clipboard from another application and you go and try to paste into Fred, it maintains this idea of like what the clipboard state was. And if you do that, it will kill the selection meta and replace it with whatever's on the system clipboard. And this is why we need the arena to be here, because this thing owns that data. Anyway, so that's a little fun piece of clipboard knowledge. Okay, so that's what we did off stream, right? We just made this arena allocated, and then we made this arena allocated, and finally I did one last thing. And Ratchet, actually, I took your advice, and I made the red-black tree. I made the free list be an atomic operation instead of a mutex locked one, right? So now we just use atomic operations to change the head of the list, and then we use atomic operations to pull nodes off of that list down here. And that's actually pretty nice. It's like, it's not super measurable right now because I don't have like tons of threads going on, but I imagine that once I get more threading options available in Fred, this will actually become a pretty big savings. So anyway, that was a cool little transformation I ended up doing. And as a result, if I go to FredBuff, if I look for std, boom, there's no uses of the standard library. The only thing I'm really using is cassert. That's eventually going to go away for my own assertion mechanism, but for now I'm just using the CRT version. All right, what are we doing today? So I have a couple of targets I want to focus on. So the renderer, I want to get all the STL allocations out of renderer. Asset loads, I want to get all the arena allocations out of that. Now, the way assets work in Fred is that I take all of the assets that are available for Fred, and I compile a separate program which takes all the assets, reads them in, compresses them, and then shoves them into a giant array that's then included inside the main application. And what the asset manager does, which is this thing here, this actually runs as part of Fred. It will uncompress those data streams and provide them to the pieces of Fred that need the assets uncompressed. Right, so we can ask some quick questions about it, like we can ask what its length is, we can describe it, which is really just like a stringified version of what the name is, and I can populate assets. So given a buffer that's appropriately sized for the uncompressed asset after you call this, fill that buffer out and tell me what ID it is based on the ID. And this is good. This works perfectly. There's no STL in here. However, with calls to populate asset, oftentimes what I do is I just set up like a little buffer here, and I think this buffer is almost always a std vector. So I think that I probably want to get rid of that and just have it be like, I think I just want to have it be a an arena allocated thing. So whatever buffer we provide for this thing, just make a tiny arena for it, fill it out, and discard it later. I don't think I actually need a std vector for it. And I'm just getting rid of more vector instantiations. This whole thing is, a lot of it's really motivated by my unyielding hate for std vector and how long it takes to compile. That thing, every specialization of std vector is just horrendously complicated and overblown in its compile time. So any chance I get to get rid of them, it's a good chance. It's an opportunity I'm taking. Okay, back to this. Syscommand. So inside of Fred, what you can do is you can open up this palette, what I call is the simple syscommand for now, and you could just execute things in here. So like I can execute dir, right? I can execute echo path, right? And there's std error and std out. So like if I make a mistake, like foobar, right? So you can see std error has something, foobar is not recognized. That's pretty good. But like with programs that have like lots of output, what I have is I have this little button over here. It says pop out to an editor. And that's super useful because I can just like take the output and start copying and manipulating it and stuff like that. Eventually, this is going to tie into the build system piece of Fred. So when you get output like this, or when the system gets output, it will probably parse it and translate them into source locations inside of Fred. So for example, if I invoked build from in here, it would build the application, and then if there were errors reported, the build system would say like, oh, okay, here's all the lines where those things appear. And inside the editor, we would just like highlight a line or something like that and say, hey, you know, this error appeared here. Similar to the Visual Studio experience of when you get errors while compiling, or with IntelliSense. So anyway, that's a much later thing that I'm going to focus on. So that's syscommand. I want to get all the vector allocations out of there. The glyph cache. So the glyph cache is responsible for populating all of the glyphs, like the text glyphs that you see inside of Fred. That thing is actually pretty nice, or at least the way I have it set up is pretty nice for now. However, there's still like a lot of STL allocations. I think there's even unordered. Yeah, there's an unordered map. This map maintains the mapping between code points and Unicode, cached Unicode glyphs. So this can be rasterized or unrasterized. That's what this flag here tells us. And this thing is just information about like, hey, when we load Unicode code points, like for example, Unicode stress, right? Like as we're loading all these things, these are not like normal glyphs. The usual ASCII glyphs are always loaded in Fred because those are by far the most common things you're gonna render to the screen. So those are all cached immediately up front because it's so fast. But these Unicode guys are kind of on demand, loaded as you're looking at them. And that's why there's two modes. So like there's the rasterized mode, and then there's the initial cache mode. So the unrasterized version is so that we can measure it and get an idea of how large that glyph is going to be for containers, like scroll containers like this. So we can tell how far we need to go like this. And then you rasterize it when you actually look at it. And that's kind of just the simple way the glyph cache works. Point is, I want to get all this STL stuff out of here. Unordered map's going to be interesting because I will need to basically create my own version of unordered map. I'm not sure if we're going to get to that today, but we'll try. And then vectors, like, just get rid of all these vectors. These just don't need to be vectors, especially because this is a fallback cache. If I arena allocate that list all up front, it's going to act like a vector anyway. So I don't really need the random access part of it. And then we have more unordered maps, right? So this is for Unicode. This is for cache fonts themselves. So if you have like different sizes of fonts across Fred, or you want a different font altogether for a certain widget, this thing tracks, or this thing will keep a reference to those things. And then the loaded font buffer, that's just pretty straightforward. Like this is the actual just font. This is the actual font itself loaded into memory. And this thing is actually part of the asset piece of it. So this is what's going to go away eventually when we get rid of the asset pieces. Yeah. Okay. And then finally config. So config is going to be a mess. And the reason that's a mess is because it's used everywhere. The actual config itself is pretty straightforward. Like, I have these DAP files that describe all of the config values. So here's the DAP files. Most of them are very simple, like they're just bools and stuff. Bools or ints or like vec4s, which are just really just 4 floats. However, there's some that's like strings. There's these complicated ones that are like vectors and stuff like that. I want to get rid of these and replace them with my internal string and then arena allocate this stuff. The question is, or the thing that needs to happen is that when I do this, I actually have to provide some kind of arena that this thing can use, which can be cleared periodically. Yeah, that's kind of why I have it like as a, if not insane, kind of thing. Because one, this thing is used everywhere, and two, the arena gets a little bit more complicated here because I essentially want to make it so that strings are split up nicely and that like if I need to discard that string value later, like say that config value changed, I want to be able to reclaim that memory back easily. And without actually just clearing the arena, I'm not 100% sure how I'm going to do that. Yeah, it's going to be a chore, I think, but we'll see. It might not be as bad as I'm thinking. Anyway, that's the stuff. I guess what I could also do actually is store them as chunked string lists. And so each string has a certain length assigned to it. This way I can reclaim those chunks as needed. But then assembling the final string value would be an overhead. Anyway, I'll think about that later. Yeah, that's the other thing I was thinking about, having kind of like a blit arena, which would have all the staged allocations for me. I'm just kind of curious how expensive that might get. I mean, it probably wouldn't be too bad. And honestly, like if I used the frame arena, because I already have a frame arena in my UI common, right? The UI state has its own arena, so like maybe I could just use the frame arena to set up all the allocations I need, clear the one that's about to be serialized, and then blit it back from the frame arena. That could probably work pretty well. Yeah, it might not be too bad. Ratchet, you're here to save the day. I really appreciate it. Okay. All right, let's jump into it though. So let's go start with the renderer. So I don't think I have any vectors here. I just have this unique pointer. By the way, basically all my objects here have their data heap allocated behind the scenes, so I don't have to have like a ton of members and stuff here. These are eventually going to be part of the main arena. So at the very start of the application, there's this main arena I set up that's just meant for essentially stuff that's going to go onto the stack for main. And this is kind of like data that will live there eventually. But let's look in here. There's no maps. There's no sets. There's only a couple of std vectors. Let's try and remove some of these things. And this is what I was talking about, where we have like these buffers stuff. So here, yeah, we're just going to do some init things. An asset buffer, right. This is just for loading the shaders. And this code is slightly different. So there's a mechanism to reload shaders in Fred. The reason that this one is a little bit different is that if this fails, then I actually can't load Fred at all. Like if the shaders can't load, then I can't display anything and the application has to terminate, which is why these are return falses instead of the actual reload shaders, which can fail optionally if like a shader didn't parse for some reason. Right. So I think the first thing I have to do here, I think I have to turn this into a single return. Let's check our... Okay. Okay, I'm just removing a vector, that's fine. So let's try and say... So let's assume true, otherwise we're going to false out of here. So we're going to break out of this outer loop. So if we're going to break. So essentially, if result was ever computed to be false, then we're just going to bail out of here. And honestly, like, I could just let this fall through and have like the if be here. But I think it's probably fine to break here. That's probably fine. I think it leads to a little bit less indentation. Okay, now we need a return result here. Okay. So now we get rid of buff here, or we actually kind of change it. And we want to change it to a string. Now, I found out this really annoying thing about the APIs in OpenGL. So if you go to compile shader asset and compile shader, so what I didn't realize early on while doing OpenGL stuff is that you can send this source length. Previously, I was sending null putter here, but if you send the source length as a pointer like this, you're telling OpenGL like how long the source is. Otherwise, it's going to assume that source is a null terminated string, and I completely spaced that because when I went to go allocate this, when I turned this into a buffer, like a vector the first time, I didn't allocate space for the null terminator, and like randomly my application would decide not to compile shaders. I could not figure out why. It's because of this parameter right there. It is an extremely important parameter. So a little bit of fun OpenGL debugging happened there. Okay. But here, because we're sending the length up front, we actually don't need to. Yeah. Yeah, you can send basically an array of strings, which is nice. Yeah, for here, we're only sending the single one. That's another thing. Like that's kind of cool, or that's kind of a cool aspect of OpenGL is that it like you can batch the shader compilations. The only reason I don't do that is because I want to be able to see like individual. I want to compile a shader and then see what the log produced based on that one explicit shader. Yeah, it lets you include things. Oh, right, yeah, like kind of like a force include mechanism. That kind of makes sense. Yeah, this thing here. I'm saying it's only one shader. Yeah. And then this is I think that's like exactly why it's a pointer, right? Because if this were an array, then this would be an array of source lengths. Makes sense. Anyway, it's kind of a cool piece of OpenGL tech that you can do that. Okay, so let's get our buffer. Or so we don't have any complex here. It's always a single shader, but it could be split up into. Oh, I see. So if you have like, I see. So if like you're appending shaders or multiple like shader sources together, you can just append them all as like one giant source. That's cool. Yeah, yeah, that makes sense to me. Okay, so our buffer. How do I want to do this? I think what I actually want to do is we have our scratch in here, but I think I want to allocate like mini scratch buffers inside of here because I don't want the arena to just get like huge depending on how big these shaders are, and some of them can be pretty big. So I'll just allocate a bunch of temps in here. You'll see. Right. So is there a scratch reset? So the scratch reset kind of happens down here whenever we end it. Um, but what I actually end up doing for the like mini arenas is I just use the temp mechanism. Uh, so temp begin, temp end. This lets me create like a tiny little allocation and then pop back to the place where it started. That's essentially what I'm going to end up doing in here. Just create a bunch of temp arenas. And actually, these breaks don't matter for those temp arenas. So essentially, this scratch is going to end up destroying whatever was allocated in there, no matter how big the temps get. So I can actually break without having to call end temp inside of any of these loops, and it should just work. So a buffer. Does it need to be unsigned char? I guess so. I guess probably so. So let's have you be null pointer for now. Okay. Yeah, so there's tons of IntelliSense errors in here, and that's the reason for that is because it does not handle anonymous namespaces very well at all. It thinks there's all kinds of ambiguities. Okay, so here's the temp I was talking about. Or, so this is the end. temp outer. And then for this inner loop, we're going to have so we want to use this should be fine. Yeah. So we destroy the inner arena because we're going to allocate a new buffer for this asset, and then this outer arena holds the buffer for the vertex shader, for which everything else is going to be computed. Okay. So now we can allocate our guy. So we got I think we could do no 0. We don't need to worry about alignment. So the size is going to be this thing. So the asset buffer. Are you unsigned char? You are. Okay. So let me actually cache this just because it's kind of easier that way. Okay. Then well, actually, I don't know. If I kind of do this in a different order, I don't need to bother caching it like this. I can just do it like this. Yeah, it's a UN64T. Okay, cool. And then we pass it in. Cool. And then on the next iteration, the arena should be right here, ended, and it will pop back to whatever it was. Okay, so we'll do the same thing here. Push array. These are pointing to the same arena, so it kind of like just doesn't matter, but well, for consistency. And actually, I could even just do this, right? Like literally, that's just a thing, so I can get rid of this completely. Just have it assigned like that. That should work. Let's see if that compiles. I also added this to Fred just so I can test compiles. Cool. So now I can build it for real. And if Fred starts, that's a good indication that we did things right. Cool. It started and I think it's happy. And we can just kind of step through here real quick and make sure things are okay. So we can populate the asset. So if we look at the buffer now, we should have, cool, should have this giant string. Yep, that looks right. Cool. I don't see any errors. Good. So there's that arena taken care of. Let's do reload shaders. This is like an identical problem. So um, we got to convert this into a single return. So let's have something like we're going to assume that it's usable. Or so if it's not usable, we've reported the issue because the reporter here actually takes care of that. And it just takes it to the feed. And you'll see like, hey, your shader couldn't compile because bad thing, or like you had a syntax error or something like that. That was back when you could actually modify the shaders and they weren't baked into Fred. I eventually want to bring back this mechanism in some form, but for now, this is just kind of how it works. And for now, it just recompiles the shaders that are baked in. So maybe I should just like disable this feature in Fred for now. But honestly, I think reloading the shaders doesn't hurt anything. It just uses up a little bit of OpenGL memory, which it then releases at a later point. So let's get back to the buffering. So let's take this out. The heck? And then or is that what it is? Yeah. And then here we need our temp arena. And we also got to close out our scratch arena. And then temp inner for this one. So push array. And then we're going to have it's going to be the same thing for this. Then this guy. Is that enough? I think that should be enough. So cool. If it's not usable, then we're out of here. Okay. Cool. Okay, so it built. Let's try to build it and then reload some shaders and see if the magic happened. So reload shaders. What is it again? I might have changed it. F6. Okay. Okay, that appeared to work. And if for some reason forgot to have that happen, I'll show you what happens if we fail to release the scratch buffer or the scratch arena. Oh, thank you for the follow. I love JavaScripts. Welcome, welcome. Doing some low-level C++-ish stuff, so I hope this can be a learning experience. Okay, so if we reload, cool. We hit our assertion, which is exactly what I expect. And if I retry, we'll see in our assert. Should expect to see, yeah, in render 1417. So if I go to 1417, which is exactly here where we allocate the scratch, yep. So it reported it correctly. So the scratch mechanism is really nice. That reporting mechanism is super helpful. Okay. So there's no more vector usage in here, which is nice. So I think that we've done enough to do this. New programs. This is kind of annoying, but because those are handles, they have to be moved into place, which is why this happens. Stream view. Okay, this needs to go away. This needs to just literally be a arena allocated thing. And because it's global, oh gosh. Oh gosh, that's annoying. Well, first let me save the progress here. That's looking good. Do a commit. Okay, let's actually build release. So this is the optimized version of Fred. And let's actually just do some coding in Fred itself. Right. Our navigation's kind of a little bit jank. Oh, thank you, 412, for the follow. Welcome, welcome. So we're going to do some coding in Fred itself and rely on the build mechanism because I can still build Fred from here. Or should be able to? No? Oh, because I'm in the build directory. Okay. So from the root directory, if I cast build, there it is. We build. And because I'm using a differently named executable, this should just work. Yep. Okay, cool. That's nice. So let's actually do some coding from Fred itself. Okay, we want to go to this thing we want to get rid of. So the annoying thing about this is that this is globally allocated, but we do have an init function which can help us which can help us set up an arena here, like a globally allocated arena meant for just texture allocation and maybe any other things that renderers need. Where do I use this thing from? Alloc render texture. I think this is used all over the place is the problem. Like, I'm pretty sure we use this even in ed. No? Where would this be used? Layout, maybe? Oh. Oh. Where would we use this thing? Dealloc render texture. Use it in create render texture. Okay. Okay, so this is the API that's actually used, I'm pretty sure. Probably layout might need this. No? Not even the command buffer API. Where is this thing used? Yeah, this is where I need a global search in Fred, or like, this is why I need a project system to see where this thing is used. Oh, it's in creating the blur texture. Right. And we need those for here. Okay. I think I'm on board. I figured it out. Yeah, I could have actually just searched here too. Right. Yeah, like there literally is. And then allocate render texture. So this thing needs to go away. So we need to replace this, we need an arena that's allocated for renderer stuff. And then we need this to be one of our internal lists. So let's get the arena first. We want to call this? Let's call it render arena for now. It doesn't have to be fancy. Right, and this thing needs to be a needs a next pointer now. This is going to be a struct. So now we're going to do a okay. Got a count of nodes. Yeah, this is not used. So we're going to find all uses of this allocator, right? We'll be using these few places. So we want to, since this can't be called on multiple, the way my graphics API works is that you can't, right now, you can't call it from multiple threads. Eventually I want to be able to change that, but because there's that invariant right now, I can rely on the fact that I don't need a mutex or atomic lock around this thing to set the list. So I can just create a node if I want to. But first, render texture data. Okay. And this is going to be our render arena. It's kind of gross that these are globals. I should probably fix that at some point, but it should be fine. I only want one of these things. Node. Texture. Yeah, and then I kind of turn it into this opaque pointer here. Yeah, so we're not going to assign anything to node yet, but we are going to insert it in the list. So I'm going to put it into our render texture list. It gets rid of this. We already have texture. Let's call it and then we reinterpret cast it. So underlying type should probably be unsigned int instead of size t. Is the only one? Is the only one? I'm going to change this. Yes. Okay. And since we pushed one on the list, cool, should be good. So we've allocated. Now we want to find the next one, which is the removal down here. So we iterate all of them. We find it. So we're trying to find a specific texture in the list. Oh, this is just a debug helper to make sure that it actually exists. I think this is still good. This is still a very useful thing to have. So instead of having this, I have a different helper. So for node here, and then we call render texture list first. And we're just going to do the same thing, right? E. We just need to be node, because nodes are already these texture data guys. So this can all go away. And then we can reinterpret cast it to this. And then deallocate is pretty straightforward. We just find it and remove it from the list. Oh, I think because of that, this might need to be a doubly linked list, because we need to be able to remove. Yeah. We need to be able to remove elements. Just kind of annoying because I don't want this to have 2 pointers. But maybe we just have to. And then we can have a free list here. Because I don't want to just deallocate them constantly, depending on how much data we have. Eventually, I want like a more generic system for handling dead data, like completely dead data. Right now, I just have like a series of free lists, and in general, that's been pretty effective. The only things I truly deallocate in the editor are things like references to entire editor buffers and stuff like this, and command lists associated with panels. So like all these panels would be deleted. But for this, I think we allocate these things so infrequently and deallocate them so infrequently that having just a free list should be safe in this particular case. So this does need to be a doubly linked list, though. It absolutely does, because this implies it must be a doubly linked list, which is kind of annoying, but meh. That's why I had this helper. It just iterates the list, but I could do it in constant time if I just have a doubly linked list. So let's just do it that way. And since we're zeroing out everything, then that's probably fine. Let me just remember. So GLL push back or push front, it doesn't actually matter. Let's just do push front. It's everything. The new ones will end up at the front. And we'll kind of just pop them off. That should just work. Okay. And so now we just have, or first we want our free list. So the free list, do I want to stick it in this thing? I think I should just stick it in this thing. Let's just stick it in there. This way, whenever we allocate a texture, we can ask the question, render texture list, free list. So at the front of this thing, if there's anything there, then we're going to use it. So if, and then otherwise, we're going to do this whole allocation thing, right? Except we don't want to create a new thing, we just want to assign it. So we have it, and is it pop front? Yeah. And then I can zero it out. I don't think there's anything that'll be necessary. It's in here. We just have an ID. This is all just C stuff, though. There's no C++ nonsensory in here, so I could just zero it. And this will zero it for us, so we're good here. And then our node. So here we actually, since we've removed it, decrease the count and then push this onto the list, the free list. We don't need to clear anything since this will just set like the next pointer of this guy. But I usually just clear it anyway. Just to be safe. Kind of like a mental note, like, hey, this is kind of just useless information now. Are there ways to remove from a singularly linked list if you kept the previous node? Yes, and that's actually what that previous API does. with the STL lists, it basically tracks what the previous node was and then removes it based on that. The other thing you could do is if you know that the node is somewhere in the middle and it's not at the end, then you can just copy the data from the next node and then delete like the next node. But here I think it's like it's pretty cheap to just keep like an extra pointer and do the double linked list thing. The extra pointer is going to be pretty small in the scale of this thing that's already pretty small. So I think it's a fairly reasonable thing to pay down for just the kind of clarity that's happening here. So let's see if this compiles. I'm guessing we're going to have some bugs to sort out. Zero memory. Did I include util? Did. Why is it not? Oh, I call it 0 bytes. This is the thing. Okay, that did compile, which is nice. So we got rid of the forward list there. Is this actually going to work though? So there's the init. There's init scene renderer. We want init platform renderer is what we want. Let me make sure this is doing what I think it's doing. Yeah, this is just going to initialize all the OpenGL libraries. And then I want an arena for my list. So the render texture list needs an arena. This thing. So should work. And just for reference, init platform renderer comes very early on, so we'll have an arena by the time we do anything with the renderer. That's basically the idea. So if I just build cool, and I can even run Fred from here, which is pretty cool. So I can do build Fred, right? Oh, everything's broken. Why are we broken? Expression found. So it's in arena line 790. So 790, what's going on here? So we asserted here because we did not find, actually I should break. Why did we not find it? For some reason, we failed to find this thing. So we were passed in a texture here, which makes no sense. And we couldn't find it. Okay. Support the program. Let's fire this up in our debugger. Weird. Okay. So it doesn't repro there? What? What the heck? Is it a node or the element in the node? It's the node itself. So this comparison is the it's looking to make sure that this texture here. So whenever I reinterpret casted this to a texture handle, it is one of these things, which are the nodes inside of our doubly linked list. And so this means that when we're past render texture back, this opaque value, we cast it back to our render texture data node, and we try to find it in the list as a debug thing. And if we don't find it, then we just explode. So actually, was this breaking because I didn't have a break here? No. What? That is wild. I don't know why that. It's like almost like an uninitialized data thing. So am I failing to initialize something? So when these things happen, I usually resort to ASAN. ASAN is an insanely helpful tool. Insanely helpful for finding all kinds of horrible issues. So let's try it. Okay. That worked. That is bizarre. And I even took out the break. So I'm not sure why this was failing. If I try to run it through this debugger, does it explode? Oh. That is super weird. That is super weird. Well, that's super weird. I'm not sure why that happened, but I suspect. I don't know. That's really weird. I'm not sure why that happened. Huh. Okay. Well, I guess I will just admit that that's weird and move on, and hopefully it will. Hopefully it'll manifest in some way I can actually track it down. But that does conclude another removal of a standard library thing inside of Fred. So that's super nice. Yeah, the arena's allocated and everything. I'm not sure what was going on there. Well, let's commit. Okay, do we have any other references to stood which are offensive? No, we do not. Okay, cool. I can call this done. So let's look at what we got next. So we've done render. Let's do some more asset loads, huh? And for this one, unfortunately, I have to come back over here and figure out where these asset loads are happening. So it's basically going to be anywhere I call this. So glyph cache is one. Okay, let's do the one inside glyph cache. So we're handed this font load buffer. Where is this thing? The vector of ft byte. So this is clearly a thing where I absolutely do need to have a an arena just for the Atlas data structure, because we're gonna not only load these asset buffers in here and keep constant references for them, because the library that I am using for font rendering is FreeType, and whenever you take a handle to a font, it actually needs it still needs the actual font loaded in memory for you to reference it correctly. If you don't have that, then bad things happen, and the library has all kinds of undefined behavior. And then we're also going to need we're also going to need an allocator for like cache font map, and then fallback font cache. So there's all kinds of good reasons why we need an arena in here. I'm just going to call this arena because we're going to use it basically for everything. We can just like stuff all of our allocations inside this thing. Since this doesn't really need to be like reallocated, this is just static. These are just static. So I think what I'll end up doing, well, maybe what I want to do is have an arena for like these things, because these don't change, and I want to keep adding nodes to this map thing. But maybe we want a special arena just for these buffers. And the reason is so I can clear them if we need to reload them. But no, they shouldn't be reloaded. They're loaded just once, I think. Yeah, they're loaded just once. I can keep them in the same arena. They can all be stuffed inside there. That's fine. So let's go to init. Okay, first things first, we're going to allocate our arena. So it's in our data, I believe. Yeah, it's in the data object. So we're going to go data. Cool. So we now have an arena with which we can load things. These font buffers are going to be the first to go. So, and we can call it the same thing. We're just going to turn it into a struct instead. I'll just call it data. And then let's default initialize these things to nothing. And we'll default initialize this thing to nothing. This is one place I do kind of appreciate C++ for, is like the non-static data member initializers. they're just useful for being able to initialize things inside of data structures that you would not normally, or like pointers in particular, and to a null pointer value without having to like touch a constructor or anything. You can just say like constructor equals default, and the compiler will do the right thing for you. Okay, so we have these loaded font buffers. Now we got to allocate them. Let's get rid of some stuff over here. Or it's actually font face buff is going to be the first thing. So try load asset. We get a reference to the data and the face buffer. So we do actually load the font face multiple times because you're able to change the font whenever you want. So like I'll kind of show you right now in Fred. So if I want to go to like Comic Sans, for example, I can do that in Fred, and that just changes the default font buffer or the default font underneath everything. But if you go back to like any other font, like let's say the default font for which there is a hotkey, you can see press Control plus F8 to load the default font. So Control F8, we load back to our default font. That actually does override this font face, the default font face. So, and because of that, because this thing can keep like reallocating and reallocating, I think I do want a sub arena just for that thing. I think that kind of makes sense. Yeah. Um, how do I want to name this? General arena, maybe? This thing can keep changing. But even like the font fallback cache can keep changing. So when we go load default font asset, we just create like a new face. This thing. But we don't delete anything in the map, which is fine. I think this is fine still. Because these are just meant for resizes of the same font. I don't think we actually clear this thing. Oh, we do clear it. If we rebuild the atlas, which does happen whenever we load a new font. Okay. So the lifetimes of cached fonts and default font face are tied together. However, the lifetimes of metadata arena is the thing that needs to be stable. Otherwise, the arena that has all this stuff is unstable, like the cached fonts, that kind of stuff. That all gets cleared whenever we change the default font. So, yeah. So this needs to be This is the metadata arena. That is like a really good name for it. Otherwise, this is the font face arena, for which stuff like cache fonts and the font face buffer go. The special font face and other things like that go in the metadata arena. Yeah, I think that's a much better place for it. So arena alloc. I'm just going to duplicate this, and then we're going to have metadata arena, and this is going to be font face arena. Yeah, I think that works out nicely. So this means that when we load a font asset, try load font asset is going to need a new parameter, which is the arena. Facebuff data. Data library. We only need it for the library. Maybe I should just pass the library, like, as a... I don't even need to pass the handle, honestly. I can literally just pass the ft_lib itself. So I can just do... library. This way it gets rid of the data parameter, because the data parameter is just like... It's such a heavy-handed move to throw that thing around. I like having things be much more explicit. And this is the arena for which we're going to allocate this face buff. So face buff. Size should be this thing, actually. Or do I use this? Okay, that's fine. And what did we call this? ft byte. And how many of these things are there going to be? This is going to be... I think I need to change that because... Oh, these need to be pointers. I need to change... There's this interaction in Fred where if you start typing, it'll helpfully come up with like a bunch of lists. But if you're in Vim mode, I think what I want to... I actually changed this kind of recently. When you push escape, it gets rid of the suggestions, but it doesn't put you into command mode, which is this thing. And I think I want it to. I want it to put you in command mode even if there are suggestions up, because I end up having to push escape multiple times. Or like if there are no suggestions like this, and you push escape, it just goes to command mode like you'd expect. I think it's just kind of unexpected to have to push escape multiple times to get back into command mode. Anyway. Okay. Space buff. Size. Data. I think that's enough. Should be enough. Cool. I think it was just get. Yeah, it's library.handle, that's what it is. the thing. Cool. And then we need to pass our arena. Cool. Let me actually go back to this data. Okay, we're good. Is this what I need? Where's the load of the special fonts? Oh, here, it's down here. Okay. Special font face. Okay, cool. And I didn't pass this through the Triload font asset because I wanted to have a special diagnostic just in case that embedded asset failed to load. That's why. Okay, that makes sense to me. Get that there. Okay. This needs to be a rep. And I'm pretty sure I'm going to hit a compiler error up there as well. Yeah, I do. Cool. And then this is going to be data ft byte. It was or metadata arena. That's what we decided on. I don't know why I bothered doing that, but that's fine. Yeah, I wanted a special diagnostic just for that thing. How far are we from being able to compile? Okay, this is the only place this is used, but font face arena here, and then when we try to load it here, I think what we need to do. Oh, this is kind of an annoying problem to be in. So this is on init. But when we try to load a font face here, okay, we actually let the system reallocate this. We only need this font face buff here. I might need to think about this a little harder because this font face is only for the built-in font. But for fonts we load through the library itself, we actually kind of just let the library handle it. And internally, FT new face deals with the problem of like loading the file, creating a buffer for it, and then free type just kind of handles it inside the face. But Rebuild Atlas does need to do a thing. So perhaps... I think we only need to do an arena clear here. And font face arena. So we want to do it here. So we can deal with the font face buffer here and then like load it as an asset. And then Rebuild Atlas will handle, you know, doing the thing of reallocating the underlying maps and stuff. So here we actually want a clear just for Rebuild Atlas. And you would think that maybe we could just stick this inside of Rebuild Atlas, but because this buffer is loaded first, we have to have the clear up here before we call Rebuild Atlas. And I think Rebuild Atlas is also a private member. Oh no, it's not. Maybe it should be. Let's see how far we are from being able to compile. Maybe there's some errors we need to address. Okay, so inside of glyph cache 716. So up here we have buffer size. Oh, it's a pointer. Center only error. Okay. Yeah, it's multiple errors on the same line, which is annoying. Okay, cool. So we're at compile mode, which is good. We're back down here. Yeah, we clearly arena here. Load the font face, which is going to be dealing with a new offset into the arena. And then we can rebuild the atlas. So let's see if we moved rebuild atlas to a private function. How devastating is that? We call it from main? Why? Rebuild atlas. Right, because rebuild atlas. Do a populate atlas, which probably pulls from the config if I had to guess. Nope. We just kind of felt like rebuilding the atlas here, I guess. we were just like, let's just do it. This seems completely unnecessary. I don't know why we need to do this. Oh, wait a second. I think I know why. I think I know why. So this is to reset the actual atlas and kind of, since we're changing all the font sizes, rebuilding the atlas is the easiest way to clear the backing texture and rebuild it with a new set of parameters. Okay, I get it now. I remember why I did this. I remember why I did it this way. Right. So this means Okay, so I kind of need to take a step back and rethink how I'm doing this. Like specifically the interaction around the arena for the Atlas, or the Atlas itself has its own arena. I think maybe eventually the Atlas itself might get its own arena. And so we keep this font base arena allocated for this guy, and we keep a separate arena just for the metadata. I think that seems pretty reasonable. Luckily, I don't need to touch it yet. So we go to arena clear here. So this doesn't need to happen. Let's kind of get rid of this idea. And okay, we're done with main. For so we have the metadata, which carries. So by the way, this metadata thing is just for little icons, like stuff like so there's these little icons like this copy icon here, or like some of the other ones you'll see around stuff like this, right? Like this pop out, the trash can, all this stuff. These are the meta icons which are involved with this metadata arena, and that's only allocated once here. And that's stuff on setup, right? So we shove the entire like TTF inside of this metadata thing, this special font base buffer, and along with anything else that might eventually be necessary for it. But for now, it's just the backing TTF file that FreeType will use directly, which is why we use memory font face or new memory face here, because we're managing the memory separately. Okay. What was my last edit? Oh, right. I said we needed a separate arena. Yes, that's correct. Okay, now we need to change this back. This is the cool thing about I just love this. It's kind of like having Git inside your editor, right? Like that's just the coolest thing. Let's add back Atlas up here and take it away from the private and then save it. Oops. Yeah, let's save before exit. So if we compile again, we should compile. Let's build it for real and see if it works. Should work, right? We still have all our icons. If I go to source ed, that all works. I can increase the font. You can kind of see the Atlas growing and shrinking with this. If I change the font, that should still work. Or what's a fun font? I always do comic just because it's like kind of silly. And I can change the size of this thing. It just looks weird. You see how it's kind of like jiggly. The reason for that is because the since this is not a monospace font, whenever we go to measure the distance here, it kind of like messes up a lot of the time. Yeah, because all the numbers are different widths and stuff. So non-monospace fonts don't work too well. And we can load our default font. Cool. That's what we care about. Let's build this with ASAN. Okay, let's load a font. Let's load the default font. Look at icons. Cool. Okay, everything seems to be working as we expected it to. And for these arenas, like we don't need to bother deallocating them at the end. Like you would think that this could be a bad thing, but by the time this atlas is destroyed, the program is done anyway. So I mean, I kind of just go with like the Casey method of saying, hey, you know, when your program closes, the OS is going to clean up everything owned by it anyway. So it just literally doesn't matter if you do any cleanups. And doing cleanups like this is just a waste of time. Okay, so let's look at our Git. So we got rid of a vector here. Cool. Let's see. So we still have this vector here. We still have one here? What's this for? Oh, for blitting. Right, we rasterize the glyphs using this thing. There's a couple of calls to this thing. We can get rid of this pretty easily. Yeah, we can definitely get rid of this pretty easily. Because I think the invariant here is that we allocate this thing inside of here. Basically what this is for is this is just for creating this is just for like rasterizing a delay loaded glyph onto our texture atlas. So if you have stuff like, so here's our atlas we're dealing with now. You can kind of see like all the letters and stuff. But if we go to something like TESS and then Unicode, you can see as we're scrolling down, there's like more stuff populating to this atlas here. That's that function actually working. Like it's like delay loading all of these glyphs as you actually need to see them. So anyway, that's what that thing is doing. Now the question is, do we need to keep, how do we want to interact with this thing? Because this thing is responsible for resizing it. Yeah, I think we end up just deleting it here. I think that's probably the right thing to do. Yeah, you pass it arena instead. And then I can make like temp regions around like loops and stuff. So so data size it's always good practice to have your arena as like the first parameter because that's kind of like the highest level thing you're gonna, or like any allocation related things I tend to put as like the first parameter. Okay, so blit buffer. And we're gonna do, the size is gonna be this. because the width times row, and then the stride is this thing here. I mean, it's kind of like a hidden parameter, but that's our stride since our pixel mode is BGRA. I mean, most of the time it's BGRA. It's pretty much never going to be the case where this fails. Let's actually move this. Split buffer. Data. The reason it was all weird before was specifically because it was a stood vector, so you had to like dereference a vector and then you could use a bracket operator. But now, since we're using like a lot more primitive types, you can just use the operators directly, and life is happy. Okay, so let's rework some of these things. Let's make sure early returns are not in here. Okay, good. Actually, there's no early returns. We're good. This is in a loop. I think we call this multiple times too. Okay, yeah, this function's kind of complicated. Okay. What I need to do is I first need to get rid of these early returns. So how I tend to do that is I switch like the early returns, at least the earliest I can return. Oh, this thing can go like way down here. I just add like a Boolean variable that describes what it's going to be. So, we assume true actually. Get rid of those early returns. Like I said, I like early returns for short functions. Like this is kind of like the maximum I would like to early return. I was doing it more aggressively because I could rely on like C++ doing its C++ thing with destructors, but I kind of want to get away from that and make it a little bit more explicit, which is why I'm removing all this stuff now. So we have result. So this entire loop can only execute if result is false. So, or if result is true. So if not equal to false, right? Here's our thing, and we're going to indent this whole block. We can get rid of this line. I need to make the indentation code in Fred kind of like a little bit more friendly to empty spaces like this, because I just end up having to kill them like that. But it's fine. That's a tomorrow problem. Okay. Okay, so if result is this, Oh, I think I put this in the wrong spot. Yes, I did. Yeah. So this loop can only execute if result is false. Well, actually, kind of like all this. None of this is applicable if result is true. So that was correct. Result is not false. Okay. Okay, so uh and or have a trim line endings. Yeah, yeah, exactly. I want all of that stuff. So my next big feature, well, interaction in the editor is I have this really nice thing that shows you all the commands, right? Like this is super nice because you can fuzzy text search for them, like split editor. But the thing is, you can't double click them or push enter to just like execute the topmost command. I want to change that, and having that functionality will actually enable me to have stuff like split lines or like sort lines or like very advanced editor features that are like less commonly used, so you don't really need a hotkey for them, but things that are discoverable from here that you can just like use on command, kind of like you can in VS Code. So like in VS Code, I can do things like highlight a bunch of lines and then like hit Control Shift P and start like looking for something that applies that selection. I want that exact same experience for Fred. That's the idea. Yeah. So eventually I want to get there. All in good time. So, okay, back to splitting out these returns. I'm actually just going to copy this and kind of paste it. Right, so we're going to break out of this loop if that fails. And then this code, here's what I'm going to do. I'm going to do another closing brace here and say like if not result here as well. I'll just do if not result. If I kind of like reading that a little bit better. So we do this block and then calculate result, and then if not, if result, I inverted it. Okay. So if result is valid, that's when we want to execute this block. If result is valid, yes. Yeah, yeah, exactly. Good catch, Ratchet. You probably caught it even before me. And I was about to make a terrible mistake. Okay, now that we have all the early returns done, we can finally allocate our scratch buffer. Um, okay. So down here, okay. Just kind of checking all this stuff out. Okay, blip buffer, yes. So for these little allocations, I think I want a little temporary arena just for the blip buffer, so that way as I allocate these things, they're kind of like scoped to just this work. Like the submit. Okay. Sure. then we terminate temp. And then here we want the arena parameter. And we do the same thing for down below. Yeah, down here. Cool. And are there any more uses? I think that's all of them. So if we go cool, we compiled. So this means that we should be able to test it. Okay. And then the best one is the Unicode stress one. Make sure that this loads properly. Yep, that looks good. So if I resize it, it should work too. Yep. It looks a little wonky there. I don't know what's going on here. I think there might be a sizing bug somewhere. Probably a sizing bug somewhere. But that looks good to me. Cool. And you can even see, like, because I ran Fred in debug mode, you can see, like, all the fallback fonts that it's identifying for specific glyphs. Lots of fun stuff there. Okay, cool. So that worked. How many vectors do we have? Fallback font cache. Do I want this to be an array, or do I want it to just be a list? Since I kind of can, I have the ability to statically allocate this thing, I think I might just make it an array. I think it just kind of makes sense. Having it be a list is just extra data that I don't need to worry, or that is just kind of pointless to provide. So I'll do it that way. So we reserve, and then we do a bunch of pushbacks, right? Here's the thing, though, like, if like, even though we reserve it, we don't use all that space, because there are some fonts that actually don't load, or that might not load. Like, it could fail to load specific fonts. Let's see if it failed to load any fonts. No, it didn't. It doesn't look like it failed to load any fonts, which is fine, I guess. Yeah, and it would have showed up actually instead error. Yep, we didn't fail to load any. But point is, even if this is an array, we might not be utilizing all the space. In fact, there's a very good chance we're not utilizing all the space, especially on Linux. So yeah, I think what I might do is I might do it as a list anyway. So. Again, just iterate them, add them to the list. Okay. And releasing these is probably fine. I don't think I actually release these things ever. Yeah, this is the only place this is used. And actually, yeah, I think this is fine. Yeah, just having it be a list is fine. I was just thinking about like invoking the destructor for this thing since it's a handle. It's like one of these scoped handle things. But I think what I might do is I might not do it as a scoped handle and just have it be FT handle or FT face, right? And this just needs to be a singularly linked list. It doesn't actually have to be a doubly linked list or anything like that because we don't remove from the middle. We're only going to be appending and then iterating. So I don't need to call it cache because it'll be named cache later on down the line. And we don't even need a free list for this thing because we're only ever going to be adding to it. Let's copy that, but delete it. And here's where the metadata arena is actually useful as well. The metadata arena can actually hold the allocations for this thing. So I think this is actually another good use for the metadata arena. So fallback font list. And since this is just a C object, we're pretty much just going to do that. And then data is going to have our arena for this thing. And I have Tracy profiling inside of here. Tracy profiling has been insanely freaking useful for identifying random bottlenecks inside of Fred. Extremely useful library right there. Highly recommend it for anybody trying to do profiling on their application. Okay, so let's get to this. Since we're already in a namespace, let's do fallback fonts. Right. We only want to push fonts to this thing if we find that they are actually going to be or that they're actually loaded. Because that makes this super simple, right? And so here I add this kind of sentinel node to say that we have like a font that's reasonable, or to say that we need to build the cache. The Sentinel font tells us we don't need to rebuild the cache. And I can still add that. It'll just be like the first node in this list. I think that's pretty reasonable. So it'll just point to like a null base essentially. FT done face. Yeah, I'll probably call this thing. Okay, fallback fonts. So if we're equal to 0, then we're going to load some stuff. We don't need this reserve. But let's actually make a separate push. Let's make it explicit. So I call it face. I'm pretty sure I call it face. Yeah. So data, the arena, and then data. Fallback fonts. And finally, we're gonna have null put it as a face. Then we're iterating. So if we can't resize the face, we got to discard this thing. So since this was a handle before, it was the destructor was in charge of actually deleting this thing, but we actually have to delete it inside here now. Inside of here, if we want to deal with it. So we have face cleanup, which handles this thing. We could just call it FT done face. I'm fine with that. And then we don't need this. FT done face. At this point, there's no face loaded. Like the library just hasn't allocated anything for us, so we're just going to continue. So we don't need to call FT done face on the face up here. But now we do want to push it. So and then face. Okay, and then here this needs to change. Find the face which could rasterize this glyph. Now, the cool thing about arenas is if you allocate linked lists in all in sequence, it kind of acts like an array. So this data structure is going to be loaded into memory like basically on the same cache line because we load 2 pointers for each node. That's not very much data. Right, we're talking 16 bytes per node. I think that's a fairly reasonable size. And you can load basically all of these in the same cache line. So even when we're calling first here and iterating quote unquote a linked list, You kind of just iterate it in sequence anyway. So we're just going to do that. Node in data fallback fonts. I think we can just delete that. If not face, if face equals no pointer, then we're going to continue. This is the sentinel face. This should be the only one that's ever null pointer. And then in face, we don't need handle anymore. No appropriate. Return the default face. Right, so this is what's responsible for rendering like the question marks. If for whatever reason we couldn't find a glyph in any of these fallback fonts. Okay. Oh, where did I make a mistake? 231. Oh, that would do it. Return 249. Oh, this is still a handle. Yeah, that is still definitely a handle, the primary font face. Okay, so if I build it, and then we're going to test on our Unicode file again. Cool. It looks like it loaded everything fine. And we can see this here. Yep, font face identified. Just like last time. And nothing in standard errors, so it looks like everything ran exactly how we expected. Cool. Wait, there actually was some error there. What is this? Failed to freeze some font bases. Yeah, maybe I should. I mean, kind of annoying. I could make it do it in the destructor, I guess. So in the destructor for glyph cache, or inside here, that's annoying. So just to kind of appease the gods. Keep done face, that's what it is. That should get rid of it. I mean, the only reason it's reporting that is because I closed the library when the atlas goes out of scope, and then the library I think has its own hook after that. So if I build red, cool. We loaded a whole bunch of fonts. Do they go out of here? And they're gone. All right, standard error is happy. I'd love to not have to do this, but you know. I don't know. maybe this is just kind of like, I should only do this in debug just to avoid the thing, but it should be fast enough in the retail version that it doesn't matter. One sec, let's check this. See how many vectors we have left. We're done with vector. How about forward list? Nope. How about std in general? A lot of std stuff still, but no containers, which is what we care about. Except for this one. To fix this, we're going to have to invent our own implementation of std unordered map, which is really just a bucketed, it's a bucketed hash table with separate chaining. It shouldn't be too hard. So maybe we'll do that, but perhaps for another stream. I'm already getting to the point where we're getting close to done with a lot of this stuff. So we did some asset loads. We did the glyph cache. Glyph cache is done, which is great. Syscommand. Yeah, that one's good. Let's see how many asset loads we have left. There's one in spell check, one in SVG. There's two in SVG actually, and there's one in tree sitter. Okay. Yeah, or just any map. Yeah, any map will work too. I think even like a red black tree map will work it just as well. There's no specific reason I have to implement it as a bucketed table with separate chaining. I only did that here because I was playing around with the STL containers and I found that unordered map performed just a little bit better than std map, which is a red black tree implementation. But I think if you're allocating on an arena heap, then I think maybe the red black tree might just be strictly better. Yeah. Anyway, let's check what our Git history looks like. Yeah, vector removal. Push back our initial font. Oh, I actually should. I know it's kind of just good practice. Cache. So I do allocate a scratch arena just for this files and dir, but because this is kind of implicitly passing an arena, I probably should check for conflicts, but realistically that's never going to happen since we know the data owns its own arena. I don't have to do that. Do not have to do that. I think there was one down here that might have an explicit one though. I thought there was. Point is, you gotta be very careful about this conflicts parameter for scratch arenas. You don't want to you don't want to create a data set that you care about and then have it be deleted from underneath you by the time it gets the caller. Okay. Just double checking this. Yeah, that looks good. Let's double check Fred again. So interestingly, the glyph cache, since I pass one single texture to all of the render passes, just so I could batch them a little bit better, you need some stable location you can pull like a white pixel from, because that's like what you're going to be mixing against everything. The white pixel in Fred is actually inside the texture, the glyph cache. So there's like this one location inside this glyph or inside this texture where I can mix colors for like these rectangles here and like this stuff, so that I only have to send a single texture to the render pipeline. Yeah, the B tree manipulation functions. Yeah, yeah, that makes sense. Yeah, trying to test out those various different types of maps is, it's kind of a pain, but I find it's worth it because you end up choosing, it's all about like choosing the right data structure for the job, right? Yeah. Okay, so that looks good. I think this version of Fred is looking pretty solid so far. Still need a hash. Still need a hash map implementation. Okay, I try to make notes for myself in my Git commit messages so I could see like the chain of work. Um, you can kind of see, you can kind of see some of these like note messages to myself where I'm just like, oh, like do this one thing on like, see like need to fix backing store, that kind of stuff. It's kind of helpful to see like what I did last time. I'll just like look at the Git log and see, oh, I made this mistakes and I need to fix it. Let's push. Okay, cool. And the cool thing is we used Fred to develop Fred, which is kind of a fun little thing I should start doing more often, especially on stream. Okay. I think on that note, I'll probably be done for today. We made a good amount of progress removing STL containers throughout Fred, and I feel pretty satisfied about the solutions that we came up with today. Okay. As usual, you could check out more of Fred's stuff on the Discord server, which you can get to from freddev.tech. From there, you can kind of check, hey, it's kind of a bare bones website, but from here, you can like join the Discord, or you can look at the tech behind Fred, which is like my blog, right, where I talk about the data structure, the buffer data structure behind Fred. And then I have a couple of other posts like undo, redo, and all that fun stuff. But yeah, the Discord or Twitter or YouTube, I'll be posting some of these streams on YouTube, or yeah, on YouTube just for posterity. Anyway, thank you everybody for joining. I appreciate your time, and I'll hopefully see you soonish. Take care.